compounds. What kind of compounds? Ionic. And we were forming the actual compound from two potential ions that would react together. Okay? So what do we have to do if I gave you two elements that are going to react? What was the first thing you had to do? First thing you had to know about the two elements. Their charges, what charge they became, right? And so we could do that two ways. What two ways can we identify the charges if I gave you an element? Yeah, they will be positive and negative, but how do I get the numbers? We can look at the group they are in. Remember? Every element has a certain number of electrons, correct? And that's given by the number of protons that are in that element. But remember, most elements don't have the perfect number, right, of electrons. Which ones on the periodic table have the perfect number? The noble gases. And so they will either add electrons or they will give away electrons to try to reach the perfect number of electrons. They never change their protons, never change how many positives they have, but they can change how many negatives they have. And then what you do is you add both the positives and the negatives up, and you're going to have an imbalance. And you can have a charge that is either positive or either negative when they become anion, or when they become ions. An anion is one that is negative, a cation is one that is positive. All right, now I have the elements in two charges. They will start to attract because opposites attract. If you have two ions that are the same charge, you won't get a compound. They will repel away from each other. Okay? So what do I look at those numbers, positive and negative? What do they need to be? Balanced. And so if I have a +2 and a -2, oh, that's easy. Comes together. If it is a +3 and a -2, that isn't balanced, is it? So what was the method we used? We called it crisscross. We drop down the numbers to become subscripts. And that will determine the subscripts. And when you write a compound, there's no space between the two. And the compound written has two capital letters. If it is an element, it's written by itself with a space, and it has one capital letter. All right? Those are ionic compounds. Ionic compounds gain and lose electrons. What are the other types of bonds that we have? Covalent. And we share those. Okay? Covalence, we haven't looked at the bonding yet, but there's going to be a difference. When you look at ionic bonds, you really are reacting two things. One, a metal, and one, a nonmetal. Okay? That nonmetal could be fluorine by itself, and that would have a -1 charge, number 9, F. Or you can have a group of ions like PO4 that has a -3 charge, and that is the phosphate group. It's a group that has a name. It works just like an ion. All right. The other way that you can identify the charge that the ion will be is from that sheet that I gave you, right? And so I'm asking you to use that sheet because you're going to be able to use that sheet when? On the exam. So if you can use that in the homework, that'll help you be proficient to use it on the exam. There's only one group that has a positive charge, and so you could have an ion that is the one called ammonium +1 and something else with it. That's an oddball one. And if you have more than one group, you always have to use parentheses to say I have 2 of these groups, okay, or 3 of these groups. But you never use a parentheses if you just have one of the groups. Why? Scientists are what? Lazy. And I don't want to have to draw extra parentheses if I don't need extra parentheses, right? All right. Now, ionic compounds come from a metal and a nonmetal. Molecular or covalent bonds are different where they share, and that happens when the compound is made up only of nonmetals. Okay, so if you look at the compound and they're only nonmetals, what this means is when the two atoms come together, and remember they throw in an electron and throw in an electron and they try to steal away, nobody is strong enough to steal from the other. And so what happens is it isn't ionic, they are sharing electrons. And we distinguish those particular compounds by naming them a little bit different. So when we see compounds, you have two kinds, ionic and molecular or covalent. We name ionics one way and we name the other ones, the covalent bonded ones, differently. You will be able to predict ionics from the atoms I give you. The covalent bonds, you don't have enough information to predict how they bond together. So I won't ask you how they bond together, but I will ask you to distinguish them and name them a little bit differently. Okay? And so we're about ready to move into naming some compounds. And so since you can put them together, we're going to try to name them. All right. Now, in terms of naming compounds, I gave you a big sheet. And if you look at this big sheet, this is a decision tree. I will not give you this on the test. You're going to have to know how to use this, okay? And what we really do is we have to decide, before we actually do naming, we have to decide which way we're going to name it. The best way to do that is to look at the first element, the first thing that you see in the compound written. Okay? You will have either a metal or that NH4 group. Okay? If it is a metal or NH4 group, then you're going to do the ionic scheme. If the first element is a nonmetal, then you use the covalent scheme. So when we look at these, our first thing is to decide which of the two methods do I use. I don't know why this is the hardest part for people. It's like they just want to start naming before they decide which way to do it. Okay, so be careful and look at them about which section we're going to do. I'm going to teach first the ionics, and then I'll teach the covalents second. All right? And each one has a way to do it, and we got to follow the rules. Okay, and so we're going to name both of those kinds of compounds. So let's take a look at ionic. So if I looked at whatever compound is on the sheet of paper, on the exam, on the board, I'm going to see either a metal at the front or that NH4 group. Now, how do I know which ones are metals? Yeah, there's that stair step, and anything on that side, and most elements are metals. Okay, if it's on that side, then I'm going to use the ionic. All right. If it is a metal or non-metal, you've got to name the front one, the first one, and the last one. And we name them differently. The cation, the one that's a metal, okay, we have to decide one thing about it. Is it weird, really? Is it a transition metal, or is it tin or lead? What is strange about tin and lead and transition metals if you look on your sheet of charges? They have multiple ones. Okay? If something can have multiple, then what you're going to have to do is tell me which one is there. Okay? So I have to have just one more piece of information. If it's not one of these, then the metal always reacts one way. So sodium up there, number 11, always reacts and becomes a +1. I don't have to tell you it becomes a +1 because there's no other choice. But anything in the transition metals or tin or lead, I have to distinguish which version I'm using. So if it's not one of these, I just use the name of the metal. That's easy. If it's sodium, you write sodium. All right? But if it's, say, it's lead, Then I have to say lead, and I have to tell you which version it is. Now, if you look on your sheet, what are the two possible versions? Lead what, and plus what? Plus 2 and plus 4? Okay. And so you would have to tell me, is it the plus 2 one? Is it the plus 4 one? I'll show you how to determine that. All right. Now, once you've named the first thing, you've got to name the last thing, the anion. If it is an element, okay, not a group, then what you do is you take the name of it, like fluorine, and you drop the ending and put "ide." So fluorine becomes fluoride. Chlorine becomes chloride. Sulfur becomes sulfide. Yeah. Oxygen becomes oxide. Nitrogen becomes nitride. And so we just drop the ending, whatever it is, and put an "ide" on it. All right? If it by chance is, okay, what is this? Polyatomic mini atoms or a group. Every group has its own common name, so you have to look up on the chart. If it's a group, tell me the group name. And so I name the front one, I name the back one, and I'm done. Okay? The biggest distinction is, do I have to use a Roman numeral to tell me what charge is there? All right. It doesn't make sense until you try something, right? And even after you try something, sometimes it doesn't make sense. But we practice. So I have a bunch of them to name here. Now, this is maybe why you have a problem deciding about, going to naming, is because on this sheet, I've just taught you how to name ionics, so all of these are ionic. If you take a look at the front one, it is either a metal or it's the ammonium. Okay, so we're not practicing that right at this moment in time. And so I look at the front end and the first one. So, oops. So if I look at this first one right here, sodium is a metal, and so the question is it in the transition or is it tin or lead? Is it in the block of transitions? No. Don't have to use a parentheses and Roman numeral. I just write its name. Sodium. I'm done with the front. Is this a group, one of the defined groups? No. The element is bromine, but when it reacts, it becomes a bromide. That is great. All right. The second one. I know it's ionic because the first element is a metal. What particular metal is this? Iron. Do I have to use a parentheses? Is it transition or is it tin or lead? It's in transition. Also, if you look on your sheet, look for iron. Does it have one charge or multiple charges? Multiple. I have to tell which one it is. Uh-oh. How in the world do I determine that? Okay. All right. Iron is changeable, but the chlorine is not. Looking on your sheet or looking on the periodic table, chlorine always becomes what charge? What is it? Not -1. Yes. And so chlorine here, when it becomes the chloride, it reacts as a -1. How many of them do I have in that compound? 2. So how much negative charge do you have on the anion side? A -2 total. So to balance that out, what did the iron must be? What must it be? A +2. Okay. And so the version that I used here was the 2 version. And is this one of the defined groups that has charge? Does this have a group name? No, it's just chlorine that's been reacted, and chlorine becomes chloride. Okay, that's good. The next one, very similar to what we just saw, right? The metal is still iron, and if we had to tell the charge last time, we're going to have to tell the charge this time, right? And the one we know that always becomes a charge that we know is chlorine. It becomes a 1, minus 1. And because I have 3, that means it has a total of a negative 3 on that side. So the iron must be a plus 3. So this time, this is iron 3 version chloride. Yes? Mm-hmm. There should be a subscript 2 after the NH4. Yes. Thank you. All right. Now, yes.
Do you always write it in Roman numerals?
Yeah, the number has to be Roman numerals. That's by convention. And so if you write a 4, the convention is IV. Sometimes you'll see 4 lines, but it's usually IV. All right. The next one is special. It is the only ion that is not a metal, but it is a group. What is the group name of that? Ammonium. Okay. And then the element that's behind it is sulfur, but that becomes a sulfide. Okay. The next one. What is the metal? Magnesium. Okay. Is magnesium one I have to designate? Yes or no? No, it's not a transition. If you look on the sheet, it only has one charge, so I don't have to distinguish it. The anion, is it a group? What is that group's name? Carbonate. All right. What is the next one? The metal is what? Aluminum. Here in America, in Britain, it is aluminium. Okay. Is the anion itself, is it a group or is it a single element? It's a group called phosphate. If you're able to answer these on this sheet using your sheet, you'll get it right on the exam. This is as complex, yes? Ah, magnesium, if you look on the chart, what charge does magnesium become? Always a +2. What does carbonate become? What is that group's charge? If you look on the sheet, a -2. A +2 magnesium and a -2 carbonate come together to be equal, to be neutral. Yeah. That 3, sometimes if you took the arrow back up, you might think it's a +3, but what you need to recognize, and this comes with practice, CO3 is one of the groups that I need to know. And I have one of those groups. All right, next. What is Cu? Copper. Okay, what do I have to consider? Its charge. And do I have to tell you what charge it is? Yes, because there are at least 2 options. Okay, so if I don't know what the cation is, I do know what the anion is. What is the anion? Nitrate. And on the chart, what charge is a nitrate? -1. So if the anion is -1, that copper must be a +1. So I have to say I use the +1 version. And you already told me what the anion is. It is nitrate. Do you see a difference in the next one? Looks kind of the same, right? It is still copper, but this time, what is its charge? 2. The reason? Every nitrate is a -1. How many do I have of them? 2. -1 times 2 is -2. So the copper must have been a +2. All right. What is the next element? Tin. Is it a transition metal or one we have to consider? Okay. What are the two options for tin? +2 and +4. Okay. Be very careful. What is the charge of this tin? It is a +4. Okay. Why is that? When oxygen reacts, what charge does each oxygen become? A -2. How many do I have of them? 2. 2 times 2 is 4, -4. So the tin had to be a +4. And then oxygen becomes oxide. Okay, so in this, the best way to determine what charge you have, if there's an option, is to look at the anion. The anion will have a defined charge, only one it becomes. Identify that. Then see how many you have. Then you'll know the total minus charge you have on one side. The ion has to be balanced to that. Okay? And every time you look at a metal, you've got to determine, do I use the parentheses or do I not use the parentheses? And if it's transition or tin or lead, you have to. And if it's not, then just name the metal, because it can only become one thing, so I don't have to tell you anything more. Covalent, remember, is where we have two atoms that throw in electrons and they can share them. Normally we think about, and most bonds are what are called single bonds, or they're sharing 2 electrons. But just to let you know, some like to share better, and so just instead of holding one hand, they actually hold 2, and they have 2 pairs of electrons, or a total of 4 holding them together. What do you think about how strongly they're held together if they have a double bond? Is it stronger or weaker than a single? Stronger. Okay. And then if you're really in love, you got one hand, or you hold someone close. If you really love them, you hold 3 hands, and then you get really close, and that's a triple bond. That's one of the strongest bonds that can occur with covalent bonds. The nitrogen in the air is triple bonded. It is not reactive, very reactive, but it does have to break so that we can put it into proteins. And really, one of the only things that will break a nitrogen bond like that is lightning. Lightning with that amount of energy will break it. The other thing, which is really oddball, our bodies can't break it down, but little microorganisms on the roots of plants can break it down. But it's a very strong bond, a triple bond. When we name covalent compounds, there are a couple of them that have common names. So if you see one of these 3, you don't name it systematically, you give it its common name. So H2O is water. CH4 is methane. Do you know what methane is? Gas. It's the natural gas line that comes out. So to your house, you get methane piped in. And then the last one is ammonia. Those are just common names. We just use, I have no idea why we've chosen those three and gave them some other name than the other way that we named them. Here is the systematic way to name every other covalent compound. The first atom will be a nonmetal, okay? And then you have two things. You got to name the front one, you got to name the back one. Now, covalent compounds are a tad easier. All right? What you have to do is you got to tell me what's in front, and you've got to tell me how many there are. Okay? 2 is di, 3 is tri, tetra is 4. And so if you got 4 of them, you put tetra in front of it and you give it its name. In the front, if you just have one of them, don't use the prefix mono. Okay? And then you have to tell me what the second element is. And you have to tell me how many there are. If it's 5, you go penta. And the last one always gets changed into an ide. So whatever it is, it's ide. So this is pretty easy. You name the two things, and you just tell me in the front how many there are by using a prefix. So this first one, I have nitrogen first, but I have 2 of them. So what is the prefix I use? Dinitrogen. And then the last one is oxygen, but it becomes, not oxygen, becomes pentaoxide. So dinitrogen, pentaoxide. I have a, ooh, that's good. I have a nitrogen, 2 of them, and I have an oxide and penta, which doesn't look like penta now that I read it. 5 of them. That just directly tells you what's there. The next compound, what's the first element? Nitrogen. I only have 1, so the prefix is mono, but I never use it first. So nitrogen, and then the oxygen becomes oxide, but what kind of oxide? Tetra. Now the next one actually follows a systematic name, but you may know what it is. The first element is what? Carbon. And how many oxides do I have? 2. Dioxide. Carbon dioxide. You've heard that before, right? That's the actual systematic name for that compound. Okay, first element is nitrogen, second element is hydrogen. What is its name? This one is ammonia. Why? Because this is a common name. And it may throw you. But remember, we have 3 that we have. Next one. First element is? Carbon. The second element is? Monoxide. Have you ever heard of carbon monoxide? It has the same shape as oxygen, so it binds into your hemoglobin just like oxygen, and it competes. And we need oxygen to live, and if this gets in the way, we don't live. The last one. Tetra, phosphorus, and then decaoxide. All right. Never use mono, di, tri, tetra with an ionic compound. That's the most common mistake I see. Just use them with molecular. That means the first element must be non-metal. Okay? One thing I want to do an example for you. All right? The first one not an example. The second one I will give an example for. So the second one is ammonium chloride. Okay? When you do this, when you make a compound from names, what you have to do is do some scratch work and then finish up. And so what I would first do is I would know by looking at the chart, ammonium is NH4 and it has a +1. And then chloride is a Cl, which is a -1. And that's my scratch work. And then I have to say a +1 and a -1, oh, they come together. Then I write on the line that as the answer. If you try to write it all on the line where you've got the charges and everything, and then you might have to do the crisscross, it gets messy. Okay? So there's scratch work and then there's putting the answer. And so separate your scratch work from your answer. Even if you use the front of the line to do the scratch work and then the other half of the line a little bit over to put the answer, that's fine, but they're two different and separate things that you need to do when you actually make those compounds. So work with your partner. So let's spend some time working on this. I do have some keys that we can take a look at if you get through, but practicing this is going to be very important for you.